I'll tell you everything you should know before you buy the brand new Bambu Lab H2D printer, including what led to this gigantic ball of plastic which completely covered both nozzles with PETG and how to make sure it never happens to you. I'll also show you what cool things you can do by combining the softest TPU and standard PETG into one print. There's a lot to cover, so let's get right into it. If you haven't watched the last video, it will be linked up above there. That one is a look at all the features, options, and accessories and my initial thoughts of this printer. This video is a result of nonstop testing of the printer using as many brands and materials as I could throw at it to find out all the good stuff and anything that came up that was a problem. At the end, I'll give you my final thoughts on this printer and where I think a machine like this is most beneficial, knowing the price point and the options. This printer is compatible with the original AMS right out of the box. Just finished my first 3-color print and I have my original AMS hooked up and the AMS2 hooked up. And this is what the print looks like. So that did work. This is the amount of waste that I had, and it saved somewhere around 72 or 73 filament changes, so quite a bit less waste. 2 of these I think were from the original purge cycle as well. I'm not sure how it was able to do this, but even on the old AMS it does give a readout for the amount of filament, and it seems to be fairly consistent except for the TPU, although that might be full. I think I've used a bit. You can see here, if I click on this, nothing happens. If I click on the new one, I have the drying options. The AMS2 works with older printers, except the dryer can't be activated just yet. There is supposed to be an update this month to make it fully compatible, but there is also a kit that may be required to be able to operate the dryer from an older machine. The old AMS and new AMS actually don't look that much different, but there are quite a few small changes that they've made. One is that the new one is slightly wider, and I think that that went into little wider openings because it seems to do a better job at fitting these spools of filament, even though on paper they don't say that it's any wider. Obviously it's a lot more accessible than the original on the inside. This one you had to take apart to access everything. This one you don't. In fact, you can even do this one-handed by pressing this in and removing the PTFE tubing. It's a nice feature also that you don't need to remove the spools to be able to unplug the PTFE tube from the back. You can just press this button, and you can see down here is where you plug it in for power. The lids are also different here. This one looks like a polycarbonate lid. Of course, this is going to be heated. What I think is probably the best feature about the new AMS, and something I've been specifically asking for, is a way to vent out humid air, which they have here. And then when the venting is complete, or when the drying cycle is complete, it closes it back up. There's no need to manually open plugs or anything like that. This printer excels at printing with 2 materials or 2 colors at once, but for anyone planning on using several colors in their prints, it is still quite a bit faster than older printers, coming in around half the time for a basic 4-color print. But the material swapping still takes some time, and there is still a purge cycle, and there will be some waste. So for the fastest prints with the least waste with this printer, 2 materials or 2 colors is best. And if you do need to change colors or change materials, try to minimize those changes. We should be getting ready to do a color swap from black to white, and it's going to be using the right-hand nozzle. We're on layer 25, and it should be on layer 26. That's cutting the filament. Should pull it back. Pulling the black back, loading the white in, and then we should be getting a purge. So that was around 2 minutes or so for that complete change. We should be getting our color change from white to red, and in this case it's going to be swapping hot ends rather than swapping filament, so it should be pretty quick. So we've got Yeah, so maybe about 10 seconds, 15 seconds. And the overall time for these prints was 48 minutes for these two. Probably one of the biggest benefits to this printer is switching the hot ends for a different nozzle size. It is fast and it does not require any connectors to be unplugged with tweezers anymore. I thought the hot ends were the same as the A1 originally, but they're not. They're just the same approach. You should know it does not like to have two different nozzle sizes installed at the same time, but I was able to override that and only print with the 0.2 millimeter nozzle, even though the other hot end was a 0.4. But when I did that, I ran into a little bit of an issue with the very first purge. So I think it's probably best to have two of the same size hot ends installed to avoid this issue. Hot end, nozzle, whatever you want to call it. There is no thermal paste needed, which did surprise me, but it works and I'm not complaining. The max nozzle temperature is 350 degrees Celsius on this printer, so it can print PPS carbon fiber, and the 0.4 millimeter nozzles are already available in the high flow versions. This printer calibrates filament automatically and it can recall which ones have already been calibrated. That saves some time and does prevent some waste as well. And it seems to work quite well. I printed all of these calibration blocks and I tested 4 different brands of filament and quite a few different materials. And I found that not only do they look clean without artifacts or VFAs, the outside dimensions are extremely accurate. The holes, on the other hand, were a little bit undersized by about 0.15, 0.2 millimeters or so, but at least they were consistently that way across all brands and all materials. The outside dimensions all came in undersized by an average of 0.06 or 0.07 millimeters, which is plenty accurate for me. So probably just a little bit more work to get those holes to come out closer to the right size. Anything I've printed so far with a 0.4 millimeter nozzle produced excellent results. The prints I've made with the 0.2 millimeter also looked really good. The top did seem to have a slight under extrusion on those 0.2 though. This is a fully automatic system for ventilation. The printer has an integrated bento box style filter. So that means when I printed ABS, for example, normally it would stink up the shop at least a little bit, and then I'd open the doors to get some fresh air in. With this printer, it seals itself up and filters the air inside during the print. For lower temperature materials, the printer vents directly out and seems to bypass the filter or have only partial use of that filter. So I think it's still better to find a way to send the air directly outside if you can. The fan on this printer is pretty powerful, so no extra fan should be required. And the flaps close automatically when the print is finished to stop drafts and bugs or anything like that from coming in. If you try and raise this up, watch what happens. Whoop, let's try to chop my fingers off. So this obviously opens up in order to use this filter for certain conditions, and that's what it's doing for those higher temperature materials. So if we turn on the chamber exhaust fan to simulate a regular PLA print or PETG print, turn that on, and you should see the flaps at the back open, and you should see the flap at the top open as well. I noticed the vent attachment is pretty deep and it goes directly backwards towards the wall. The hose turning also takes up some space, and the printer itself is 20 inches deep. So this printer with the hose attached needs at least 27 inches from front to back. My bench in this case is 24 inches wide and it was already 3 inches away from the wall, so it just barely fits. The heating up of this bed is off the charts. The bed heats from 20 to 70 in 1 minute and 6 seconds, 20 to 90 in 1 minute and 45 seconds, and the chamber can heat to 65 degrees Celsius, which is the max of this printer, in about 10 minutes. I've tested printers with fast bed heating before, and bed warpage was always a problem. This printer, on the other hand, lays down really nice first layers every single time. And so I've got the thermal camera. And let's heat that bed to 70 degrees Celsius. and it was taking about 1 minute and 6 seconds to get to temperature. Let's see what happens. Oh, wow, that's cool. It's at 43 already. So here the average is 30 on the surface. So at 70 on the printer, we are at a maximum 58. It's climbing quickly. And it looks like it's evening out quite a bit. So the average is only 51 on the surface. So normally this is a problem when it heats too fast for most printers, but I'm not sure if they're using thick aluminum, whether it's a composite material or if it's some sort of ceramic. Whatever it is that they've used, obviously it's working. And you can see the temperature after just a few minutes has unified quite a bit over the entire build plate and over the entire bed. So that definitely is thick aluminum, quite a bit thicker looking than 1/4 inch. It looks like 3/8 of an inch to me. I'll grab a measurement. So the total thickness is 11.48 and it's about 2.5 millimeters on the top thickness there before the aluminum. So that brings us to about 9 millimeters for that aluminum thickness. Pretty good. I don't know why it's 9 millimeters. That seems like a strange number, but that's what I'm getting. Because of the dual hot end setup on this printer, the build volume is a bit strange. You can fill the build plate with separate little prints, and that'll work as long as the parts on the left or the right are printed with only the material loaded in the nozzle that reaches those areas. What this really means is that we can't have a single print that fills up the entire width of 350 millimeters on this printer. I think it's a pretty rare problem, and as usual for longer parts, they can just be added on an angle. So far, I've only had one poop come into the build chamber, and it was during the first purge using that 0.2 millimeter nozzle.
Wow, I just noticed that the purge for the 0.2 was massive. So I'm not quite sure what's going on there, and it ended up flopping into the build chamber. I did not expect that. There's just way too much purge there.
Usually, printing with PETG is the biggest problem with poops coming inside the build chamber, and with this printer, it is no longer a problem, though I have used one application of Slice's plastic repellent. They've released instructions on how to replace most of the parts, and I will have to confirm this, but it looks like even the Z screws and nuts are going to be accessible on this machine, but as long as they're regularly cleaned with the rod sloth and an old towel and then re-greased, they should last a really long time anyway. When they addressed the filtration and prevented smells from high temperature filaments from stinking up the house, they also made the printer pretty quiet because the door is now always closed during the print. I'm getting a max of 54 dB, about a foot or less from the door, and even at the end of the print, it doesn't seem to get any higher than that. The print quality on this machine is quite good. It has made some of the best, if not the best prints that I've ever seen. What jumps out the most is the lack of VFAs and the really nice layer alignment. On occasion, you'll see some of the internal structure still telegraphed through, and this seems to only happen when I print with multiple colors, which does affect the extrusion paths. There are a lot of cameras on this machine. The live view camera, time-lapse camera, can see outside of the printer, and it caught me a few times picking my nose. So there is a little cover that came with the printer to block that camera off. But if it's a big issue, I'd actually cover the side window completely, and that's what I did with mine because it was looking right at my computer screen. I haven't found a way to view the nozzle camera yet. I know that's probably not an issue for most people, but I still like to access it. And if there are errors like clumping, it'd be really handy to be able to check that nozzle camera view to see if the print can be resumed without having to open the door and look inside. So Bambu, if you're listening, hopefully you can add that feature for me. There's a bird's eye view camera, which looks directly at the bed, and then of course the macro lens camera, which can only see right in front of it, so I don't consider either of those to be a problem from a privacy standpoint. So with that red brick carbon fiber filament, there is always a bit of buildup on the nozzle, and thanks to the nozzle cam, it identifies that problem, and that's great when you're awake. But I ran quite a few prints at night, and the notifications didn't wake me up. So the print was paused for several hours. Now when that happened, the print must have cooled enough to cause something to shift, and that led to that visible layer alignment issue. Now I should mention that regardless of the printer I use, that this filament is causing that same problem with buildup on the nozzle. The nozzle cam monitoring feature can be disabled to stop the print, and that works as long as the print isn't too long and that the clumping doesn't get out of control. Which leads us directly into the cause of that huge fail that led to this giant ball of plastic that nearly ruined the entire printhead. So it was late one night and I was getting a 6-hour red basic PETG print started, and I was getting a bit tired of the notifications from the nozzle camera telling me that the little bit of buildup was there. So I made a decision to completely disable the camera monitoring. I applied glue stick because it was a heavy duty print, and I let the print go for about an hour and didn't think anything of it. When I came back to check on the print before going to bed, I discovered this. I stopped the print right away and I kept the nozzles warm, and luckily I was able to remove most of the mess pretty easily. It took a while to get rid of all of the little bits of plastic that were hiding around the back of the nozzle, and you know PETG is not the easiest thing to clean off, but I had these dental picks and they worked really well. I knew that using my older red basic PETG was causing buildup on the nozzle, but from my experience it wasn't going to be enough to cause a big problem. So what actually did cause the problem then? To keep this printer going non-stop, I didn't thoroughly clean the build plate when I rinsed off the detergent. Some residue was still on there. How do I know this? Well, I've never actually had a print come off the build plate during a print when I used glue stick, and it wasn't a problem before this, and it hasn't been a problem since. So to test that, I didn't clean the build plate, I just applied glue stick, and I had the exact same issue. And when I stopped the print and I re-cleaned it properly, the problem was gone. The source was a massive lapse in judgment, human error, also known as stupidity. I haven't completely figured out why one of the nozzles broke. I believe when the right-hand nozzle came down, it hit a clump of red, and that's when it broke. The white hot end then retracted up and got out of the way, not causing any more problems. To this day, the 0.4 millimeter high flow nozzle can still be seen inside of that white blob of PETG. So if it wasn't clear on how to avoid this problem, don't turn off the thing that tells you when you're doing stupid things. And if you're going to do stupid things, make sure that it's not caught on camera. Really though, I think I'll just use PETG High Flow. It doesn't seem to have any buildup issues. The other thing is this printer allows for multiple levels of sensitivity. Turning it to low is a much better option than turning it completely off. I had these quick grip clamp pads that I designed and I made out of white TPU a little while ago, and they have been working great, but they've never actually looked right. So let's see what results we can get when we mix a 95A yellow high flow TPU and basic black PETG. So these ones are for my small clamps, and they also fit better than the originals do so that they don't slip off and get lost like the originals did. So we just need to be careful with which materials we actually mix together and that they bond fairly well. PETG and TPU seem to bond really well, but PLA and TPU don't seem to bond quite as well. The small pads turned out great, so let's go ahead and we'll print the larger ones too. They're basically the same, just a bigger version. So I want to take it one step further and print an even softer TPU. And I have some 90A TPU, which is super stretchy. I've never actually printed with this before. When I tried to feed it in, it was having trouble pushing out the old TPU, so I had to go through the cold pull process to remove the existing filament. And it also happens to clean the nozzle out too. The cold pull takes about 5 minutes, and after that I was able to feed it in with no problem. I also found that this really flexible filament doesn't like to go through the side-mounted spool holder guide. It flexes way too easily. So I ended up running the filament against the side of the printer, and I added some electrical tape to make sure that it didn't make any marks long term. Normally pink isn't my color, but this is what I had, and since I was using one pastel, I'm also going to use another one. I have Prusa Chalky Blue PETG for the text. And a while back I made a video showing how you can use fuzzy skin to make your prints look really good. And so I've included it on these prints as well. I have a micro fuzz though. It's a 0.1 by 0.1 fuzzy skin. And even though the final result is very pink, it does look pretty good. This one definitely has more flex than the yellow, and it seems a bit more grippy too. Bambu Slicer also has added some new features in order to get the different materials to mesh even better, and I'll be experimenting more with those in the future. So there's a few little things. Some of the softer TPU poops like to stick inside the chute, but after about 3 or 4 poops, it seems to come out on its own. There's a lot more headroom inside this printer than other printers, which means no more rubbing of tubes on the bottom of the glass and wear because of that, or scratches on the top cover. There's no stop for the first layer inspection, which is another little time saver. I want to share my final thoughts on this printer, but before I do, if you're enjoying this type of content, make sure you hit that like and subscribe to help this channel out and keep me going strong. I do quite a bit of design work, and when I see something that is this well designed and engineered, I have a lot of appreciation for the expertise and time it took to create it. But the reality is that it is the final product that actually matters. So after testing this machine nonstop, how did this printer perform and who would benefit from it the most? If you do mainly dual color printing and you aren't into tinkering too much, you just want your printer to work, this printer is going to be a great option. Now, when I first looked at the price, it did seem a little bit high, but after comparing the specs, the H2D is packed with a lot of new features and improvements over their existing printers. And it is literally more than twice the printer of the X1C, coming in at 31 kilograms or 68 pounds to the 14 kilograms or 31 pounds of the X1C. The X1C, I think, currently is $1,200 US, but it is less than twice the price, currently at $1,900 US for the printer. That's the base printer that comes out, I think it's going to be in June. It isn't twice the printable width or the printable depth, that's true, but with a single nozzle, it can print slightly more than twice the volume of the X1C. Now, just like all the Bambu printers, the H2D worked right out of the box. The X1C was the same for me. It's fast, it has more reliable and fully automatic filament calibration for all filaments. It has excellent first layers as long as you don't leave soap on your build plate. It's quiet, it has more added safety features as well. And once you experience the quick swap nozzles, you will not want to go back to anything else. And of course, now you can mix different materials together or just print in dual color without much waste. Adding one more color or another material makes a pretty big difference in the final look and function of a product, especially if you're going to be designing something to sell. It's really the sum of all of the parts and all the improvements that make this such an impressive machine. And at this point, a few hundred hours of prints in, I'd have no problem recommending this machine to anyone looking for a solid workhorse of a printer for their home or for their business. What Bambu continues to do with their printers is include more and more features and continues to innovate and make even better products. And that continues to push the competition as well, which ends up being a better thing for us. I'll give you one example of what I mean. If you look at the back there, at the nozzle wiping system. Look how they've included small rollers on there. So that's going to make it a little bit quieter. It's going to have less friction as well. And all of those parts are going to last a little bit longer than they would otherwise. Just a small thing, like I said, but it's neat that they were paying attention to those small details. Last minute, I also decided to do a straight comparison between the X1C and H2D. Both of these were printed with a 0.8mm nozzle and the exact same spool of red PET G filament for the best possible comparison. And the X1C, you can see on the top, has a slight amount of VFAs, otherwise it's a pretty clean looking print. And on the bottom here, this is what I was trying to say earlier, you can't really see any VFAs. If you do, they're very, very faint. So they've done something different with this machine to be able to try and eliminate those VFAs, which might come down to the change in the belts that they've made or maybe some other fine tuning as well. If you have any questions about this machine, let me know in the comments down there and I'll try and get back to you right away. And for anyone wondering about the laser for this machine, I will be covering that, but to keep this video as short as possible, I'm going to have that one as a separate video. I don't want to reveal too much just yet while I'm still testing, but what I will say is that it did change my mind, and I think it might change your mind too when you see how it works. As always, if you're enjoying this type of content and you want to help support this channel and you're in the market for a printer, I have a very short list of affiliate links down there below. And thanks to Bambu for sending this machine out to test out. And thank you to each of my patrons for helping to support this channel and making videos like this possible. Take care, and I hope to see you on the next one. I'll tell you everything you should know before you buy the brand new Bambu Lab H2D. H2D. All right, let's do it one more time. I'll tell you everything you should know before you buy the brand new Bambu Lab H2D printer, including to see if the print can be resumed without actually having to open the door. Without having to open the door. Can be resumed without having to open the door and look inside. I'd love to see somebody come up with an idea to be able to, at the back here, funnel different materials. I'm not sure if this is possible, but maybe interacting with the machine it would be, to funnel different materials into different bins, and that way they can be recycled over time properly.